All right, so here we are going to start on normal distributions, and this follows our discussion on binomial distributions and discrete distributions. So we have looked at the different types of distributions, and what makes a distribution, as we have seen, is the size of the distribution. So when it comes to normal distributions, the biggest part or the biggest discussion is centered around the normal curve. The normal curve gives us the properties of the normal distribution, and these ones I need to highlight that they are highly examinable, so you can get some marks just by clearly understanding the properties of the normal curve. So the normal curve is showing on your screens right now, and as you can see, it stretches from negative infinity to positive infinity. The curve does not touch the x-axis, or what I may call the horizontal axis. When you look at the curve, it is symmetrical in the middle. Now the midpoint is the mean, whereas the standard deviation runs alongside the curve. That's why it is smoothed the way you see it on your screen. So we move into the properties of the normal curve. Number one, as you have seen on the screen, it is bell-shaped. Number two, it is symmetrical about the mean. Number three, it extends from negative infinity to positive infinity. And then number four, the total area under the curve is equal to 1. So these are very, very important properties of the normal curve, and for us to be able to derive the appropriate probability, we shall need to make use of these properties. We shall straight away go to the probability of the normal. And as per the discussion on your screen, we are saying that if x is the normal variable or distribution, and then mu is the mean, that being the standard deviation, that being the variance, then the normal distribution is denoted as per this equation. The normal distribution is denoted as per that equation. So to find the probability of the normal, you need to find the area under the normal curve using the standard Z tables. You need to find the area under the normal curve using the standard Z tables. So under all cases, we shall be converting the x, which is the normal random variable, into the z. We shall be converting the x into the z. And to support our foregoing discussion on normal distributions, we are going to use December 2010 question 3 part B. And according to this question, the time taken to deliver the items, of a particular type of goods from warehouse B to warehouse C is known to be normally distributed with a mean of 5 hours and a standard deviation of 2 hours. This is typical information that you're going to be given by the examiner for you to be able to work out the required probability. So they have given us the mean as 5 hours and the standard deviation as 2 hours. So we are required to compute the probability that the time taken to deliver the items randomly selected will be less than 6 hours, okay, as our first part, less than 3 hours as our second part, and between 3 and 6 hours. Now, of course, for you to be able to clearly understand how to compute the normal, how to compute the probability of the normal distribution, I will include an extra question on top of these three, and that is the equal to. I want us to first of all look at the probability that the time taken is 6 hours. Then we can move into less than and greater than. That will be quite easy. So as I've mentioned, if you're required to compute the probability that the normal random variable is equal to 6 hours, you need to convert the 6 hours into an appropriate z-score. So for us to convert our x to z, our z is equal to x minus the mean that is given divided by the standard deviation. So in our case here, our x is 6 minus the mean that is given as 5 hours divided by 2 hours. So that is 1 over 2, which gives us 0.5. Therefore, if we are talking about probability that x is equal to 6 hours, we are as good as saying probability that z is equal to 0.5. So after getting the z as the random variable, we shall now go to the tables to read off that probability. However, before you go to the tables, we shall need to first of all sketch the normal curve representing that probability, or to identify the area of the required probability. So when, of course, we standardize our normal random variable, the x, it becomes a z. And as per the properties of the normal, the curve is symmetrical about the mean, so it means that the mean cuts the curve into 2 equal parts. The standard deviation is 1 for a standard z. So here I'm talking about z, and of course our z, we have obtained z as 0.5, which is positive. So the required area that represents the probability is the area from the center of the curve, or I would say from the mean, which is 0, to the z that we have obtained as 0.5. Maybe before I proceed, I need to also indicate that this curve is exactly the same as the curve. Of course, the mean is given as 5 hours. Standard deviation is given, which is x, as 6 hours. So this would represent the probability of the x, which we have converted into z. Now, of course, as x, before standardization, the standard deviation is given as 2 hours. So this is the curve before. Okay, let me use those figures there. This is the curve, the normal curve before standardization. This is before, and then this is the curve after we have done the standardization. So of course you may not have all the time in the exam to draw the curve before and after. So what I encourage you to do is to just sketch the curve after you have done the standardization. Now, what I need to also mention, the questions that I usually get from students time and again regarding this, is exactly what happens to the 5, what happens to the 2 when you standardize. Of course, we have seen that the x, which is 6, when you standardize, it becomes 0.5. Now, when you standardize, when you standardize the mean, which is 5, it reduces to 0. So in all the cases, I'm going to be representing the mean as 0, and then the standard deviation becomes a 1. The standard deviation becomes a 1. So in all the examples I'm going to give, I will indicate the mean as 0 and the standard deviation is 1. So this is when you are done with the standardization, when the x is converted to z. Okay, when the x is converted to z, the mean becomes 0, which was 5. Of course, we are given 5, and then the x will depend on what you get as z. The standard deviation becomes 1. So please take note of that, because of time and again from experience, I've been getting questions regarding where I get the 0, where do you get that 1. So the 0 is the standard mean. When you standardize, the mean becomes 0, and then the standard deviation is a 1. When you standardize, the standard deviation reduces to what you've been given to a 1. So we are done with this. This is the curve that you need to present in the exam. Just present the curve after you're done with the standardization. Now, as I've mentioned, the area of the shaded part is the area which is probability that z is equal to 0.5. That is the area. Z is equal to 0.5. So what I need to mention is that the examiner will give you the Z tables. So you straight away go to the tables and read off the required probability. So right now I'm going to take you to the tables so that we can identify the probability that Z is equal to 0.5. Okay, so this is one of the past papers that of course represents the standard examination, December 2021. And you're going to find, I've talked about the tables, you're going to find the tables at the end of the question paper. This is the list of the formulas you're going to be given. Then at the end, the next page definitely is where you're going to find the table that you're going to use to read off the probability. So the title of the table is Cumulative Normal Distribution. That's the title, and there is a sketch that accompanies that table. This sketch, critically look at it. The way it is shaded represents the probabilities that have been given in the table. So as you can see, the area that is shaded is denoted as P, whereas the area that is not shaded is has been indicated as Q. So it means that the probabilities that are given in this table represent the shaded area P. Now, good enough, our sketch exactly looks like this the sketch on the table. So it means that I can actually get the probability that Z is equal to 0.5 straight away from the table. So I'm going to read off this. Of course, this is my Z right here. Then I look for 0.5. This is my 0.5. Now, because I don't have a second decimal place, I'll read from the column indicated as 0. So meaning that this is 0.50 and the required probability is 0.1915. The required probability is 0.1915. So you come back here and indicate that the probability that you say therefore, I hope I have enough space here. So we shall say therefore probability that x is equal to 6 hours, which is exactly the same as probability that z is equal to 0.5 is equal to 0.1915. So that will be the probability that the time taken is equal to 6 hours. So it is as simple as that. Just maybe to review the steps. Step number 1, what you do, depending on what you're given in the question, you represent that mathematically. And of course, this is not part of the question, but I'm just using it to clearly explain the difference between equal to, less than, greater than. Because if I don't do this, then it's going to be a bit confusing for you to get to know what is equal to, assuming you're given probability x is equal to, probability x is less than, and probability x is greater than. So the very first step you take is to convert the z to, to convert the x to z. The very first step you take is to convert the x to z. So when you achieve that, the next thing is to sketch. You sketch to identify the area of the required probability. Compare this shading with the shading on the graph, the shading on the table, and then depending on the nature of the shading, you read off the required probability. So I want you to go to the next lecture video that covers this first part of the question, which is, if I take you back, we are now going into the real parts of the question. So since we have understood how to compute x is equal to, so the next thing is to look for Roman 1, probability that the time taken is less than 6 hours. So I wanted to go to the next lecture video and capture that discussion, and then we can be able to complete all the other parts of the question. Thank you.